Owners of power plants at remote locations like mining sites, off-grid communities, and islands are looking for hybrid solutions to replace the use of fossil fuels. Wind and solar are the most common renewable energy sources. The challenge is to make maximal use of this intermittent energy to provide reliable power supply to end users and to lower the cost of energy. Danvest has invented a simple solution. Unlike standard gensets, Danvest-equipped gensets are able to operate lower than the 30% load threshold for longer amounts of time. They even go all the way down to zero load. Danvest will dump energy peaks and will respond fast at all times. By low-loading the engines, a very high amount of wind and/or solar penetration can be achieved. Danvest is based on the reliability of diesel generators, and mainly diesel expertise is needed to operate a Danvest hybrid power plant. The dump load system controls the power balance during periods of surplus renewable energy and assists the genset during fast load variations. The plant controller consists of normal diesel engine controllers and a Danvest hybrid plant controller. A magnetic clutch is fitted between the diesel engine and the alternator. The preheater system maintains an optimal temperature of the engine during low-load operation. The cooling fan is operated separately from the engine. The pre-pressure system ensures pressure in the combustion air receiver during low-load operation. As wind and solar are intermittent energy sources, and as power demand can also fluctuate, the Danvest system always has to be able to instantly add or absorb energy. It works as follows. The left graph in this screen virtually shows the amount of load that is supplied by renewables. The right graph shows the amount of load that is supplied by the diesel engine. Together, they cover local power demand. When renewable energy is not available, the genset provides power like any other genset. Wind or solar energy is now increasing. The genset decreases load and controls voltage, frequency, and power balance. When the genset dives under the 30% load threshold, the pre-pressure and the preheater system becomes active. This is the beginning of the low-load operation. Wind or solar energy continues to increase, and the genset continues to decrease load, still controlling voltage, frequency, and power balance. When renewable energy covers 100% of the demand, periods with excess amounts of renewable energy will start to occur. The alternator will then more and more reverse its operation and will start to draw the engine. The engine functions as a soft dump, but is still driving the alternator. The genset continues to be in engine control mode until bursts of excessive wind or solar energy cannot be dumped in the engine any longer. The frequency will start to rise. When the frequency hits 50.3 Hz, engine control stops and dump load control takes over. The alternator is still dumping energy by drawing the engine. Overflows of energy are dumped in the dump load. When the dumped amounts of renewable energy become stable, the engine clutches out and stops. The spinning alternator does not stop. Connected to the bus bar, it always provides reactive power, electrical cadence, and mechanical inertia. Also, the preheater and the pre-pressure system of the engine stay active at this point. With the engine off and the system in dump load control, controlling voltage, frequency, and power balance, the system is solely running on wind or solar power. The only sound that you can hear is the buzzing sound of the spinning alternator. But the wind can fade away and dark clouds can appear. A significant drop of renewable energy is handled as follows. When the dump load controller senses that renewable energy is decreasing, the diesel engine starts. It starts fast, as it is already warm, pre-pressurized, and is disconnected from the alternator. It then clutches in to add load. The dump load system assists in creating power balance and in keeping the frequency stable. Overall, this adaptation takes only a few seconds. Danvest generates its high fuel savings in a smooth operation and without the use of energy storage. Storage systems to shift renewable load are optional, and as the storage system will not be used for load balancing, the amount of charge-decharge cycles will be kept to a minimum. The main benefits of Danvest are a stable supply of reliable power, very high wind and/or solar penetration, enormous savings on fuel, the use of robust and existing components, and reduced levelized cost of energy. Danvest makes hybrid power work for you.